Hello everyone, myself Shalini, doctoral student in Functional Materials and Energy Devices, Department of Physics and Nanotechnology, SRMIST. We focus on designing and fabrication of copper-doped MoS2 grown on carbon fabric for variable thermoelectric applications. Here we have designed and grown pure and copper-doped MoS2 on carbon fabric by hydrothermal method. The growth of pure and copper-doped MoS2 on carbon fabric is confirmed by the Raman characteristic peaks, that is A1G mode, A1G mode, D band, G band. And we have also calculated the frequency difference between E1G mode and A1G mode, and it was varying between 26 centimeter to 24 centimeter per centimeter. And this results in result shows that few layer of MoS2 has been grown on carbon fabric. Further, by using the Raman analysis, we have calculated the ID by Ig ratio, where it was 1.16, 0.53, 0.81 and 0.94 and 0.66 for respective samples. Further, we have analyzed the FSM analysis, where FSM analysis showed the nanosheet like morphology for MoS2, and the growth of MoS2 and copper-doped MoS2 was uniform and dense throughout the carbon fabric.
Further, the temperature-dependent thermoelectric properties were analyzed from the electrical conductivity studies. The semiconducting nature was confirmed, in which the electrical conductivity increasing with increasing the temperature. Along with the same 6 samples showed the best electrical conductivity, and the Seebeck results were also resisting the semiconducting behavior, and the sample CM4 showed the best Seebeck coefficient values. In order to confirm the enhancement, we have analyzed using the all measurement analysis. From this analysis, the enhancements of Seebeck coefficient was contradictory from the MOT equation. If the Seebeck coefficient is increasing, the carrier concentration should decrease. In order to explain this, we have considered and proposed a model in which we have considered both substitutional copper atoms as well as interstitial copper atoms. Initially, if you consider the substitutional carbon atoms, then the carrier concentration will be much smaller and than the additional copper atoms, whereas the substitutional carbon atoms acts as the acceptors and make low Seebeck coefficient. But when we consider the interstitial carbon atoms, they likely to form clusters, and these clusters introduce the interface between the copper and. But when we consider the interstitial copper atoms, they are likely to form clusters, and these clusters introduce interface between copper and MoS2, in which low energy carriers will be filtered by allowing the high energy carriers, and this leads to enhance the Seebeck coefficient. Further, we have fabricated a variable thermoelectric device by taking CM4 as a p-type material and copper as an n-type material, and this was interconnected using the copper tape, and then it was placed on various percent amps and checked the thermoelectric voltage, where the percent P3 showed the good thermoelectric voltage of 190.7 microvolt at 8 Kelvin. This paper was published in the Journal of Colloids and Interfaces with the title Enhancement of Thermoelectric Power Factor by Electron Energy Filtering in Copper-Doped MoS2 on Carbon Fabric for Variable Thermoelectric Application, and it has been selected as an inside cover page in the Journal of Colloids and Interfaces and Sciences. Thank you.